Hi and Assalamualaikum. We are from class RAS 11340. Want to present about polymeric scaffold in tissue engineering. My name is Nur Isa binti Mat Yunus. In the last almost 10 years, the field of tissue has grown rapidly, which is offering for generating almost every tissue of the human body. The field of tissue engineering is complex and requires an in-depth understanding of all components of the in vivo and in vitro environment, which is highly multidisciplinary field that combines the principles and technologies from the life science, material, clinical medicine, and engineering science to develop the functional of tissue. In tissue engineering, stem cells are important tools because of their capacity to differentiate into a large number of cells according to the stimuli provided. For example, embryonic stem cell and adult stem cell. The tissue engineering aims to improve or restore tissue function that are defective by reconstructing the tissue. Polymeric scaffolds are important subject for tissue engineering. Scaffolds are defined as a three-dimensional porous biomaterial designed to perform some of the functions such as promote cell biomaterial interaction, permit sufficient transport of gases, nutrients to allow cell survival. The field relies extensively on the use of porous 3D scaffold to provide the appropriate environment for the generation of tissue and organs.
My name is Nuratika binti Muhammad Burhanuddin. I want to talk about polymeric material. So there are several types of polymeric material used in a tissue scaffold. For the first is a PLLA. So what is PLLA? PLLA is a polylactide or polylactic acid. It is due to the chiral nature of lactic acid, and PLLA is the product resulting from the polymerization of L-lactide. Secondly is a polyglycolide or polyglycolic acid, we can call as a PGA. PGA is a biodegradable thermoplastic polymer, simplest linear or aliphatic polyester. It can be prepared through polycondensation or ring opening polymerization. And then the third is a collagen. The amino acid composition of collagen is a typical for protein, particularly with respect to its high hydroxyproline content. The next is a HA. HA is an hyaluronic acid or hyaluronan. HA is an anionic non-sulfate glycosaminide glycan distributed widely throughout connective, epithelial, and neutral tissue. The last material, PCA. So what is PCA? PCA is a polycyanoacrylate. Commonly used abbreviation for patient control analgesia. So analgesia simply means to relieve pain. So PCA is a method by which the patient control the amount of pain medicine they receive. So that's all from me.
Assalamualaikum warahmatullah. My name is Nur Shazwani binti Samsul Bahari. So today I would like to present about the properties of the polymeric scaffold. First, I will explain about the several properties of PLLA, which is polylactide. Completely, PLLA is very soluble in solvent with 0 mg per milliliter. PLLA is a fiber-based device. Because of that, the fibers will exhibit excellent heat-resistant property even at 200 degrees C. PLLA also can come in the form of injections or widely used as a botox. The second properties of materials is PGA, polyglycolide or polyglycolic acid. PGA can be used to regenerate biological tissue. If PGA combined with fibrin, it will create a very successful tissue adhesive and give a much stronger sealant than other biomaterial combination. PGA also have a good physical properties, consists of melting and boiling point, also the density. Next, collagen. Mostly, collagen give a lot of benefit towards our body that will support tissues and give cell structure outside and inside. Generally, collagen has a great tensile strength and will strengthen blood vessel in tissues development. After that, HA, hyaluronic acid. First, it will promote angiogenesis. Angiogenesis is the physiological process through new blood vessels form. HA also plays an important role in skin healing process. Lastly, PCA, polycyanoacrylate. PCA can be used as a synthetic surgical glue, skin adhesive, and an embolic material. It also is a major component of skin and other musculoskeletal tissue.
My name is Nurul Shahira binti Abduraza and I will talk about method used in polymeric scaffold in tissue engineering. There are actually 10 methods, but I will explain only 2 methods, which is microsphere fabrication and fibrous scaffold fabrication. There is freeze-drying technique in microsphere fabrication. This process involves the use of a synthetic polymer that is first dissolved in an appropriate solvent. After dissolution, the polymer solution is cooled under the freezing point, resulting in a solid solvent that is evaporated by sublimation to leave a solid scaffold with numerous interconnected pores. When the solution is cooled to freezing point, the solids can be separated in the ice phase, resulting in a small porous structure characterized by a fence of metal surrounding the ice. The scaffolds are achieved after consequent drying by simple dissolving and freeze drying. The macro porosity corresponds to the empty area initially occupied by ice crystal. Freeze-drying technique is more suitable method in biomedical application because the use of water and ice crystal instead of an organic solvent during scaffold fabrication. In fibrous scaffold fabrication, there is nanofiber electrospinning process. The charged liquid under high voltage leads to the interaction between the surface tension and electrostatic repulsion that causes droplets on spinneret to erupt and stretch. The strength of the electric fields exceeds the surface tension of the droplet to produce a liquid jet that is then extended and whipped continuously by electrostatic repulsion until it is deposited on the grounded collector. The solvent evaporates in the process and the jet is solidified to form into a non-woven fibrous membrane.
Assalamualaikum. My name is Siti Rabiah binti Hamzah. I will talk about the advantage and disadvantage of using scaffold in tissue engineering. As we know, scaffold is made from polymeric biomaterial, which provide the structural support for cell attachment and subsequent tissue development. The major advantage of using scaffold in tissue engineering is scaffold have multiple components and tissue-specific composition. Firstly, ECM provides structural support and physical environment for cells rigidity in the tissue to attach, grow, migrate, and respond for sickness. Secondly, ECM, which stands for extracellular matrix, give the tissue its structural and therefore mechanical properties such as rigidity and elasticity that is associated with the tissue functions. Thirdly is ECM may actively provide bioactive cues to the rigidity cells for regulation of their activities. For example, the RGD sequence on fibronectin triggers binding event. There are several disadvantages that we can find if using scaffold. First is architecture. Scaffold should provide void volume for vascularization, new tissue formation, and remodeling so as to facilitate host tissue integration upon implantation. Next is cyto and tissue compatibility. Scaffold should provide support for either extraneously applied or endogenous cells to attach, grow, and differentiate during both in vitro culture and in vivo implantation. And last one is bioactivity. Scaffold may interact with the cellular component of the engineered tissue actively to facilitate and regulate their activities. That's all from me.
The application for freeze-drying technique is tissue engineering scaffold, and for nanofiber electrospinning process are wound healing, drug delivery, soft tissue synthetic skin, and also scaffold for tissue engineering.